Hello, viewers. Welcome to another episode of Knowledge Sharing. Today, we are looking at this question and it says, simplify cube root of square root of 5 minus 2. So, we are going to simplify this for us to see what the value of this question looks like. So, we are given from the question, cube root of square root of 5 minus 2. What is this? We are going to solve this without using calculator. And at the end of the day, when you punch your calculator, we compare the two answers. So from here, when we have a question like this, we will say let cube root of square root of 5 minus 2 equals to x. And also cube root of square root of 5 plus 2 equals to y. So when we have this, what we are going to do next is for us to clear this cube root. How do we do that? We introduce the power of 3 to both sides. This will become cube root of square root of 5 minus 2 all to the power of 3 equals to x to the power of 3. Then for y, we have cube root of square root of 5 plus 2 all to the power of 3 equals to y to the power of 3. So from here, we can see that 3 can cancel here and 3 can cancel the cube root. 3 can cancel here and 3 can cancel the cube root. Therefore, we have x to the power of 3 equals to, it will only remain square root of 5 minus 2. And this other side, we have y to the power of 3 equals to square root of 5 plus 2. Let's call this equation 1 and let's call this equation 2. So what we are going to do is for us to subtract equation 2 from equation 1. So in that case, we'll have that to the power of 3 minus y to the power of 3 equals to, this way will become square root of 5 minus 2 minus square root of 5 plus 2. So for us to open this parenthesis, this will become x to the power of 3 minus y to the power of 3 equals to square root of 5 minus 2, then y times square root of 5 become minus square root of 5. Then minus times plus 2 will become minus 2. So this is the same thing as having x to the power of 3 minus y to the power of 3 equals to, this is the same thing as square root of 5 minus square root of 5 minus 2 minus 2. So this will go, this will go. We are now left with x to the power of 3 minus y to the power of 3 equals to minus 4. So this is what we have as x to the power of 3 minus y to the power of 3. So we have this. So the next step is for us to, okay, we have x and y. What we are going to do is for us to multiply x and y. So we say multiply the value of x and y. So this will become x times y equals to, our x is cube root of square root of 5 minus 2. We multiply by cube root of square root of 5 plus 2. So this is what we have. This is the same thing as we call that. So note, when we have n root of a times n root of b, is the same thing as n root of a times b. So expressing this in this format, so we are going to have x y equals to cube root of square root of 5 minus 2 into square root of 5 plus 2. So in this case, we can see that inside the square root, we have difference of 2 square. Or we recall, we can see that when we have, say note, we have a to the power of 2 minus b to the power of 2 is the same thing as a minus b into a plus b. So this is what we have inside the square root. So we are going to express this in this format. In this case, this is our a and this is our b. So x, y will be equal to cube root of, since we are representing this in this format, a to the power of 2 is square root of 5 all to the power of 2 minus b to the power of 2. Our b is 2 to the power of 2. So here, we need to clean this. So here, we have x, y equals to, in this case, we have square root of, okay, here is cube root. Cube root of 2 will cancel here and 2 will cancel the square root. We are now left with 5 minus 2 to the power of 2 is 4. So here will become x, y equals to cube root of 5 minus 4 is 1. We all know that cube root of 1 is 1. Therefore, our x, y equals to 1. And we recall that we have x to the power of 3 minus y to the power of 3 equals to minus 4. So from here, this is different of 2 cube. You say note, when we have a to the power of 3 minus b to the power of 3, it's same thing as a minus b all into a to the power of 2 plus b, ab plus b to the power of 2. So expressing this in this format, we have x minus y all into x to the power of 2 plus xy plus y to the power of 2 all equals to minus 4. So another one, we recall that when we have x minus y all to the power of 2 is same thing as x to the power of 2 minus 2xy plus y to the power of 2. So from here you can see that we can rearrange this. This can become x minus y all to the power of 2. When transposing this into this other side, it becomes plus 2xy equals to x to the power of 2 plus y to the power of 2. So you can see from here, this equation, we have x to the power of 2 plus y to the power of 2. So when we rearrange this will become x minus y. We are going to rearrange this. Then into x to the power of 2 plus y to the power of 2 plus xy all equals to minus 4. So what we are going to do is for us to substitute this and put in this. So this will become x minus y all into, here we have x minus y all to the power of 2 plus 2xy, because this is what we have here. Then we bring down this plus xy all equals to minus 4. So this is what we have. We need to clean this. So from here, let's transfer this to this other side. We have x minus y into x minus y to the power of 2 plus x. This is 2xy plus xy will give us 3xy. Then we have all equals to minus 4. So here we can expand this. Expanding this times this will give us x minus y all to the power of 3. Then this times this will give us plus x minus y, then times 3xy equals to minus 4. So we recall that here we have our x, y equals to 1. So we are going to substitute that where we have this. So this will become x minus y all to the power of 3 plus, here will be x minus y, then times 3 times 1. So this is minus, all equals to minus 4. This is same thing as x minus y all to the power of 3. By rearranging this will become plus 3 into x minus y all equals to minus 4. You can see that inside the parentheses we have x minus y and x minus y. So we'll say let u equals to x minus y. So substituting this into where we have u to the power of 3 plus 3u equals to minus 4. We can rearrange this. This will become u to the power of 3 plus 3u. When this transposes into this other side, it becomes plus 4. All equals to 0. And this is the power of 3. And it's a cubic equation. And we want to replace this 4 for find a value or a constant that is raised to the power of 3. So this 4 can be written as 1 plus 3. And this one can be 1 to the power of 3 plus 3, the same thing as 4. So we are going to replace this with 4. So this will become u to the power of 3 plus 3u plus 1 to the power of 3 as this plus 3 equals to 0. Collecting like terms, we have u to the power of 3 plus 1 to the power of 3 plus 3u plus 3 equals to 0. And here we see that u to the power of 3 plus 1 to the power of 3 the same thing as when we have a to the power of 3 plus b to the power of 3, the same thing as a plus b all into a to the power of 2 minus ab plus b to the power of 2. So we are going to represent this in this format. So this will become u plus 1 all into u a to the power of 2, the same thing as u to the power of 2, minus 1u. 1u is u. We have u, then we have plus 1 to the power of 2. 1 to the power of 2. This is for this. Then we bring down this. We have plus 3u plus 3 all equals to 0. So this is what we have. So we need to clean this. So as we said, let's bring down this. So we have u plus 1 into u to the power of 2 minus u plus 1 to the power of 2. 1 to the power of 2 is the same thing as 1. Then we have plus. Here will become, we have 3 here and we have 3 here. We can factor it out. So we write, well, let's bring down 3u plus 3 all equals to 0. So from here, we can see that we can factor this out. So we have u plus 1 into u to the power of 2 minus u plus 1. Then we have plus 3 here is common. 3 into u. 3u divided by 3 give us u. Then 3 divided by 3 give us plus 1 all equals to 0. You can see that we have u plus 1 here and u plus 1 here. They are common. We can factor it out. So we have u plus 1 into, dividing the whole of there by u plus 1 will give us u to the power of 2 minus u plus 1. Then dividing the whole of here by u plus 1 will give us plus 3 all equals to 0. In this case, this is the same thing as u plus 1 into u to the power of 2 minus u plus 4 all equals to 0. You can see that we have two parentheses here. It is either this one equals to 0 or the second one equals to 0. And the second one is quadratic equation. So let's set u plus 1 equals to 0. Or we have u to the power of 2 minus u plus 4 equals to 0. So what we are going to do now is, this other side will be u equals to, when 1 transpose into this other side, it becomes minus 1. So this is the value of u that we have. So this second one, which is u to the power of 2 minus u plus 4 equals to 0. We are going to check whether we have the solution of this root or the solution of this equation have real root by using a discriminant formula, which is discriminant equals to b to the power of 2 minus 4ac. So in this case, we have the value of a equals to 1 and value of b equals to minus 1 and value of c equals to 4. So substituting this parameter into this discriminant, which is equals to b to the power of 2 is minus 1 all to the power of 2 minus 4 times a, which is 1, times c, which is 4. So we have minus 1 to the power of 2 equals to 1 minus 4 times 1 times 4 will become minus 16. So the value of this discriminant has no real root. So it's going to be rejected. So it has no real root for this other side. They have no real root. So what we are going to concentrate is u equals to minus 1. And recall that we said that our u equals to x minus y. So here we recall that u equals to x minus y and value of u equals to minus 1. So we have minus 1 equals to x minus y. So in this case, we can rearrange this by moving everything to this other side. So here will become, when this transposes into this other side, we have minus 1 plus y equals to x. Therefore, making y the subject of this expression, we have y equals to x plus 1. So this is the value of y that we have. And also recall that our x, y equals to 1 from what we have here. Let's clean this and move forward. So we can clean this. So we said we transfer this. We have y equals to x plus 1. And recall that we said our x, y equals to 1. So when y equals to this, substitute, this is the former equation that we have. So let's substitute the value of y, which is x plus 1, into what we have here. So this will become x into, in the place of y, we put x plus 1, all equals to 1. So let us expand this. X times x, we have x to the power of 2. X times 1, we have plus x equals to 1. Therefore, x to the power of 2 plus x, when 1 transposes into this other side, it becomes minus 1 equals to 0. And this is a quadratic equation. We are going to use a quadratic formula for us to find the value of x that we have. Recall that we said that our x from the given equation equals to cube root of square root of 5 minus 2. So this is what we are looking for, the simplification of this. We set x as this. And now, so we are going to look for the value of x from this equation using a quadratic formula. Quadratic formula is in the form x equals to minus b plus or minus square root of b to the power of 2 minus 4ac all over 2a. From this equation, our value of a equals to 1, and our value of b equals to 1, and our value of c equals to minus 1. So substituting this parameter into where we have here, we have x equals to minus b, which is minus 1, plus or minus square root of b to the power of 2, which is b 1 to the power of 2, minus 4a, our a is 1, times our c, which is minus 1, all over 2. So this will give us minus 1 plus or minus square root of 1 to the power of 2 is 1. Then we have minus 4 times 1 times minus 4 is going to become plus 4. So this will become 1 plus 4 all over 2. So in this case, our x equals to minus 1 plus or minus this same thing as square root of 5 all over 2. We have two solutions from this equation because it has plus or minus. So the first one, which is x1 equals to minus 1 plus square root of 5 all over 2. And the second one, which is x2 equals to minus 1 minus square root of 5 all over 2. So these are the two solutions that we have. And one of them is correct in the sense that we recall that we said the whole of the value of x, which is this, must be greater than 0. So in this situation, we have that when we see minus and minus, that means it is minus, which is this x2 is less than 0. So when we have here minus 1 plus square root of 5, we know that square root of 4 is 2. So when we add 2 to minus 1, it becomes plus. So the whole of x1 is greater than 0. Therefore, our value of x that we have that satisfies this equation is minus 1 plus square root of 5 all over 2. So this is what we have, and it satisfies this equation. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.